Hello and welcome. In this video we are looking at how to calculate the percentage by mass of one atom inside a compound. So for example, calculate the percentage by mass of hydrogen in water. Now what that means is if we take the relative formula mass of water, what percentage of that in terms of relative atomic mass is actually hydrogen. Now the way we work this out is we have to use some maths. There's a formula I'm going to give you that will help you to work it out, but you're actually not given this formula in the exam. In the chemistry unit 2 exam, you're not given any formulas at all. You are given a data sheet with a periodic table in it, but you are not given any formulas, and the reason for that, I guess, is because they're testing your math skills as well as your science skills here. So the formula that you can use, though, if you want to go that way, is this one up here. It says percentage by mass is the relative atomic mass of the element, and that's the element that you want. The element that you want divided by the relative formula mass of the compound. So in this case, we're going to work out the relative atomic mass of the hydrogen, and we're going to divide that by the relative formula mass of the whole compound of water. Now one thing you've got to be careful of here is when you look at the formula, there's a little 2 here, so that means we have 2 hydrogens and not 1, and so we've got to make sure we incorporate that into our calculations. Now we can't do anything just yet until we get some extra information, and that extra information is the relative atomic mass of hydrogen and for oxygen. So let's try this one out and see how we do with it. Okay, so we said here it's the relative atomic mass of the element that you want, and we've got to remember to take into account the number of atoms we have. So we've got hydrogen, the relative atomic mass is 1, and there's 2 of those because we've got H2, so we have 2 altogether on the top, and on the bottom we want the relative formula mass. Now I'll just quickly show you how to do this, but if you are a little bit confused by it, I have made a video just today or yesterday that shows you how to do this, so you can have a look back at that and look at that in a bit more detail. But for now, the relative formula mass for water is H2O, so it's 2 hydrogens, so that's 2 plus the relative atomic mass of oxygen, and that's given here, and that is 16. So we have 2 divided by 18. Remember here, squeezed in over there, you've got to times it by 100 to work it out as a percentage, so we do times 100, and that is 11.1%. Okay, so while they don't give you this formula in the exam, they will give you the relative atomic masses that you need to work with. You won't have to memorize these. So a second example we can do is Na in NaCl. So I want to work out the percentage by mass of sodium in sodium chloride, and again we need that extra bit of information, and that is the relative atomic masses of the atoms, and we want Na in NaCl, so that would be Na, the relative atomic mass is 23, and that's divided by the relative formula mass of the compound, so that would be 23 plus 35.5, which is 23 over 58.5, I think 58.5, I think that's right, times it by 100, and then we get 39.3%. So what we're saying is the relative formula mass for sodium chloride, NaCl over here, is 58.5, and of that 39.3% is the sodium. Okay, so that's a second example right there. Now what's probably a good idea is if you have a go at a few yourself. Here are all the relative atomic masses you need for these 3 questions, written them all out there for you so you don't have to go looking them up. And we've got the first one is carbon in propane, which is C in C3H8, nitrogen in ammonium nitrate, which is N in NH4NO3, and chlorine in magnesium chloride, which is Cl in MgCl2. So it's probably worth pausing here, having a go at these 3 yourself, and then you can check your answers in a moment. So in terms of carbon in propane, we've got carbon, but we have 3 atoms of carbon. Our carbon has a relative atomic mass of 12 right there, so we say 3 12s, 36 divided by 36, and we've got H8 here. Relative atomic mass of hydrogen is 1, so that would be 36 for the carbons and H for the hydrogens. That would be 36 over 44 times by 100, remember, to get a percentage, and the answer for that is 81.8%. So that means that for the relative formula mass for propane, 81.8% of that actually is the carbon. Okay, so for nitrogen, here we go. Just quickly go through this one for you as well. A little trick here. There's no number next to the nitrogen, but do look carefully. There are 2 nitrogens there, and the relative atomic mass of nitrogen is 14. So we'll have 2 of those. That will be 28 over 28 plus 4 plus there's 3 oxygens. So oxygen has a relative atomic mass of 16. So 3 of those would be 48. Simplify that bit, that would be 28 over 32, 72, 80. 28 over 80, don't forget the times 100 for the percentage, and the answer is 35%. And the last one down here, chlorine and magnesium chloride. Relative atomic mass of chlorine is 35. Remember, be careful, there's 2 of those. So we have 35 times 0.5 times 2 is 70 over 70 plus 24 would be 70 over 94 times by 100. We get an answer of 74.4%. So there you go, 3 examples to practice on. Hopefully you've got that, but if not, you can go over it again. As I say, if these terms like relative atomic mass and relative formula mass are a little bit confusing, you can go back and have a look at the other 2 videos I've done on those 2 topics. But for now, that's me done. Thank you for watching, and I'll see you again soon.